Hello, good day. My name is Joshua Welsh and I'll be taking through another pure math tutorial. So from the last episode, I left you guys with a question to do. I'm sure most of you couldn't answer it, and that's okay. That happens a lot in the subject, honestly. But the thing with this was, we needed a way to prove that this is equal to 0. The problem is that if you look back at the other video or in your notes, which you should have notes, there is no multiplication. There's no way to multiply two numbers and get 0. At least not an axiom for that. But we know it to be true. So how do we know it? So what we do is we have to use two variables. We have to use x and negative x. So we have to say, let x be a member of the set of all real numbers, so the axioms can work for them. And if x exists, then there has to be a negative x. So what we do is we just do a normal add inverse. X plus negative x is equal to negative x plus x, which is equal to 0. So we know that this x plus negative x will give me 0. So what we do is we substitute x plus negative x into the equation. So we say u times x plus negative x is equal to x plus negative x times u. Did I say that right? X plus negative x times u. We then use a distributive law to say ux plus negative ux is equal to ux plus negative ux. We say for one side, we say that is equal to 0. So we're saying that ux plus negative ux is equal to 0, which is true. So because this is true, we proved it using the add inverse and the distributive law. We can say that u times 0 is equal to 0 times u, which is equal to 0. So we proved it not by multiplying, but by using the add inverse and the distributive law. I have one more question for you. I think this is going to be a short video. One more question for you. Next video, we're going to start proof by induction, which is more challenging, but less like this. I prefer induction, and induction comes. Before I go into this question, while I'm talking, you can start this question, try it. Direct proofs by deduction, they rarely ever come in Cape barely brings them. The last time they brought them was in 2012, 2013. So if you're doing this for exams, you need to understand the concept, of course, and try it. But if it's very difficult for you, don't beat yourself up for it. It most likely won't come. And for 4 marks, you could afford to lose 4 marks. In a 150, the exam is like 150 marks, so you could afford to lose 4 marks. Right, so if there exists a value x, which is a member of the set of all real numbers, then when you minus negative x will give you x. Now again, we know this to be true. We learned this in Form 1, but how do we know this is true? I mean, it makes sense to us, but how do we know it's true? So that's the whole point of this. These stuff are basic, like the stuff you will learn in Form 1, but now you're learning why. Now you're learning why the stuff you learned in Form 1 is true. Now I'm going on to the answer. For this one, you need to, like the other one, you need to first create a value y. So there exists a value y, which is a member of the set of all real numbers. I think that makes sense. And y is equal to negative x. So what we're saying, so now we come and put an equation. Y plus negative y is equal to 0. We know this is true because of the add inverse. But then we say negative x. No, okay. So now you take this and substitute it in. So you take what y is and you substitute it in. So you say negative x plus negative x, because this is y and it can negate it. So negative x is equal to 0. Still true, but we haven't proved it yet. We add x to both sides. So that's why I did it in purple, so in case someone gets mixed up in like why, where did the x come from, where did this x come from, where did this x come from, I just added it to both sides. It's fine, just do it. Add x to both sides, and what you'll see is that this side will just become x, but this x and this x will cancel each other out. So what we're left with is negative x is equal to x. That makes sense. And we just proved the proposition. So you're seeing how direct proofs work. Because this is like not as important. I don't want to say this is not an important topic, but this is not a crucial topic. It's a baby thing that like nobody really does, but you just need to understand and appreciate it. So if you want, I will put more questions up in a video and explanations, but I think I will just go on to proof by induction, which comes almost in every exam and is actually hard for most people to do. So yeah, that's it for this episode. Stay tuned to the next one.